talking about a really buzzword compliant topic. It's Industry 4.0. Maybe you've heard before, so be warned, there might come some more buzzwords in these slides, and of course cats. So Industry 4.0 is a thing I will talk in a couple of minutes after the advertisement block. So we are not doing only SMW business, also a lot with data integration, business intelligence, ontology engineering, and so on. So we have contact also to other fields of interest in the industry. So this is the driver why I made this topic for my talk today. We have some customers you might know, others you might not know. We are working with different technologies, so not only the MediaWiki SMW part, but also with Atlassian Confluence and Information Workbench, which is also, by the way, an interesting semantic wiki if you're more about Sparkle, RDF, and standard compliance things. We are working with RabbitMQ, which is an open source messaging broker activity, open source workflow engine. So most of the topics are open source. Pentao Palo is BI, and then of course the more semantic parts, so with some RDF stores, Protégé, and so on. So Industry 4.0, as I said, this is buzzword compliant, which means all the important politicians, all the big companies, all the big players are jumping on that story. And it started, I think, back in 2011 at Hannover Messe, where this has been the headline. We are now at Industry 4.0. And if you Google around, you will definitely find this chart. It's from DFKA, showing that this is the logical next step we have to go to Industry 4.0. Sorry. And there's also, meanwhile, an initiative in the US. It's called Smart Manufacturing Leadership Coalition. So smart is nowadays also one of these buzzwords. So if you have, or you don't like to say something semantic, just use smart. And it's about the computerization of the manufacturing industry. So manufacturing industry is huge. Computerization is huge. If you bring it together, then it's even more huger than before. And the goal is, again, the smart factory. Smart. What does this mean? Smart in this case means something like a collective intelligence. So if you have a gap somewhere, you can do it like these arms, help each other, and you get out more if you work together. Sounds great, and we have the same idea with SMW. What are the use cases? Machines that predict failures, trigger maintenance processes autonomously, self-organized logistics and supply chains, mass customization. So if Jeroen would like new running shoes, he can go to the Adidas or Essex page, type in his name, and then he gets his new shoes branded, something like this. So you have still mass production, but more user-centric. So these are the main drivers. And of course, efficiency is a driver, so you have all the business KPIs here as well. Yeah, by the way, here's the cat. So this is something that shows the idea behind it. So you have, let's say, a production line with smart machines. You have smart products, something like, oh, please do me first, or do you have time to work on me further, or can you make me black or blue or whatever? So all the things are in a communication, and to help out having gaps in the production line, for example. So the smart factory is about communication of smart objects. Of course, cloud is involved. Cloud is important to have here, and services in the cloud. So anyway, but you have, let's say, the smart product. This means the product itself has some kind of intelligence. I come later to that point. You have the control room on the shop floor level. You have your business applications like SAP, Oracle, or whatever. And you have the machines that are used within that production line. And all of these parts should be connected together. Some of these parts are already connected together today. For example, the machines, you have this field bus technology. They're now about using more Ethernet and so on. So there are some challenges to make this actually happen. And one buzzword again is the digital object memory, they call it. So there is a passive one, and it's more or less like, okay, having a unique identifier for your product. That's used today already. You have different flavors of barcodes, QR codes, or whatever. You have RFID to uniquely identify a product or a piece. But this means if you'd like to have additional information about the product, you typically need to have a lookup within a server, which resides in your factory. So if I have production information about my new running shoe, because I'm the manufacturer of running shoes, and during the supply chain I move that running shoe to a shop, the shop is not able to get more metadata about the shoe. Where has it been produced, on which day, and so on, because that's on the server of the manufacturer. So to get things more self-contained, you need to have something like an active digital object memory. And with these little devices, so this is a Raspberry Pi, by the way, it's running a SMW stack, so it's a full lamp stack here in it. This is around 25 to 30 euro. So this gets really cheap, and you have everything you need within that piece. So you have LAN interface, you have USB, you can plug in wireless, you have microprocessors, you have I/O ports as well. So with having this, you can really create some value added to products. Maybe it's not a mass product like something to eat or to drink, but imagine there are more complex products that's not too expensive to add. And there are different, it's Arduino and Raspberry Pi, you might know from your home shopping center. You can get it really easy, but there are some industrial devices also available. And adding this to the physical layer, you get some cyber physical systems. That's also one important thing. So the idea is here, or what I was playing with, is how to become SMW part of this whole landscape. How could that fit in? And first question, why semantics? I can use anything to add some storage here. The interesting thing is you have, okay, we are here all aware of the ontology and the advantage. So industry currently has bits and bytes. They have the PLC description, function blocks, and so on. And that's quite new to this manufacturing area. So there will be something like a factory ontology. And the current discussion is like in, more or less, I would say, in every knowledge domain, they are discussing about what's in the ontology. So the technology is ready, but how to fill really the data model, that's currently part of the discussion. Let's have a look at the technology. You remember the picture with the robots and so on. So to make things communicate with each other, it's important to have at least some kind of standards for the different layers. Of course, you need some plugs if it's not wireless. Ethernet TCP/IP is currently the main building block for the communication layer. Then you need something for the messaging layer. OPC UA is something that's around for years now. This is a big consortium, and they are really part of this whole story. But you can use cheaper and more lightweight things like AMQP. I will show a demo of this later on. You have the semantics layer. You see there's OWL, OWLS. They have OM++ defined, and so there are different flavors of describing the semantic layer and the service layer. And on top of that, you have something that drives the business processes or the production processes. Really a high-level architecture could look like this. So you have the communication bus here. And you have your products with the active object memory. You have something like a service directory. Let's say, which machine in my production line is able to solve something. You can look up the service directory within the factory, or you can look up the cloud. Is there something outside my factory that can provide that service? You have the factory memory. That's a smart database. You can query about everything in the factory. This is not just a CRM system or an ERP system or whatever. It's really the box where the box for one truth, let's say it like this. And this could be a semantic box powered by Semantic MediaWiki. Then you have your machine and devices layer with a machine memory. There also you can place a Semantic MediaWiki. And as you see, you have several SMWs in one factory. Now you have to question, okay, how to sync the data between these things. And now things really become interesting because that's a self-contained thing. So I can move the product with its self-contained SMW and can move it somewhere else and have the complete semantic model with it. So that's the idea, having these distributed SMW instances. So I will show you a small part of this with a live demo. What we did is started a couple of days ago creating an extension for SMW to get the hooks from the MediaWiki and push some messages on a message bus so that others can consume that messages. That's currently something that's not so much used for MediaWiki. We have a semantic watch list that does this very well for some semantic changes, but does notification by email. We have the email notification, of course, but then we have more or less some polling mechanisms. So is there something new in the wiki? Is there something new? So you have to repeatedly ask your data model if something changes. And with that extension, you can hook on the different events that can happen and create some messages. So AMQP stands for Advanced Message Queuing Protocol. You can Google for RabbitMQ, that's a good starting point, and you can have different patterns implemented and you have a lot of language bindings. So this is really, really nice to implement, really fun. And then other thing is the way back is pushing data to the SMW. I'm not sure if I have enough time to show you something. Maybe talk to me in the coffee break. I can show you an example how to use an extract transform load tool, also open source tool, to write back data to the wiki, and here we go through the API. Okay, time for a live demo. Okay, so actually Christian Ligneto created 3 years ago an extension already for, he called it MediaWiki Push, which was an implementation of an AMQP stomp message extension for MediaWiki, but so this is more or less that, I would say. It's not maintained, so I took the code and have a look at it. Not sure if we can build on that. I think this will be a complete rewrite in the end, but anyway, the idea has been around for some times. I also might borrow some code from Semantic Watch List, for example, to calculate changes in the semantics for the notification mechanism. So how does this work? So let's say we have a wiki page here and create something new. Just checking that the page doesn't exist. Save the page. So now I go to the message broker. I have some queues here, and I have one for the MediaWiki. And you see this is the timeline, and I see that there is one message arrived there in my data queue. Then I can go down. Let's say I just get the message. And here in the payload section, I currently see a huge bunch of JSON. So this is a transport mechanism. It's language agnostic. You can put anything you like. Here I currently use JSON, so this is something that's interesting, what format can be used for transporting semantic data. Could be RDF, XML, whatever. It could be some JSON schema as we learned today. Whatever you'd like to push can be added here as a payload. So if I create a new page, of course we get an additional message. What did I do with the special characters here? So now the second message arrives, so this is persistent currently. It's not automatically removing because there's no consumer that takes the message from the bus, so it stays there until someone says, okay, I delete it. And depending on your implementation pattern, you can have a producer-consumer pattern, you can have something like a WAN out, so like a broadcasting, whatever. Yeah, that's the one direction. The other direction is, I will show you, oh Jesus. So this is activity. So you have an Eclipse plugin and you can define your business processes here. You have all the nice things to draw business processes. Actually what's in here is a little bit of JSON. Oh my goodness. So here I connect to the localhost as guest. I use the test queue. I create a little bit of JSON here, connecting to the RabbitMQ, set host, set username, and so on. Say, create a new channel, and that's it. That's the groovy implementation of how to communicate with the message bus. You see, it's really a 5-liner. It's easy. So if I run this, so there's a unit test behind it, drives that. Okay, now it's on the message bus as well. I go back here, go to my queues. We said it's the test queue, and what a surprise! The message is also here. I say get message. This is just for the debugging, and I see here's my JSON. So using that technology, you can really have, instead of a polling mechanism, really a more or less on-time, real-time messaging between different components. And for me, this is really a building block to have MediaWiki being part of such an architecture. So it's really in an early state. You can have a look here, and you see it's the old layout for extensions. Still, it's message files is missing and I18N is missing. So basically what it's doing, it's making a registration to the hooks. I think in the meanwhile it's also global and so on. So the syntax is the old style, but that's the idea, to have the hooks. For example, article delete complete, article undelete. Currently I'm watching the article insert complete and the SMW store update data before. That's the place where the link or the borrowing from semantic watch list will come in to, let's say, make a notification on the message bus and to put the properties that has been changed into the payload. And then you can think of the picture with the 3 instances of SMW. With that mechanism, you can create something like a synchronization between these wikis. Built on a message bus, so this means it's not only SMW as a consumer, it can be anything. You can create adapter, for example, if you like to create a new project, the new project gets created within your wiki, it gets created within your ERP system, it gets created into different file systems, whatever. So you have one point where a user can enter things, and to the message bus, the information is distributed. Okay, that's for now. Questions, ideas? Or is everyone hungry? or sleepy.
Any questions to this topic? Okay, probably after lunch.
No, if you have any questions, also to have a look at these devices or whatever, just talk to me.
Yeah, so if you plan on implementing Semantic MediaWiki as a receiving end of such message queue?
Yeah, then we need something like a daemon running, for example, and the daemon will be a consumer for the message queue. So this is nothing that's using polling, it's really using notification mechanisms. And then I would either do just so this is the ETL tool, and you can create, let's say, the complete API workflow for MediaWiki within that tool. So this is, let's say, a graphical editor for the API. And you can trigger that kind of jobs from the daemon. That would be the way I would like to have. Or you create a daemon and just directly implement the API calls. That's the other way around. That's if you would like to push data to the SMW. It's a valid question.